As we approach the mainland of Antarctica, you can see how far the ice shelf extends off the coast of the continent. Roughly the size of the U.S. and Mexico combined, Antarctica is almost completely covered by a thick layer of ice. Moving inland, we can see that Antarctica is much more than an endless plain of snow. A new study by researchers at NASA finds a rapidly melting section of the West Antarctic ice sheet appears to be in an irreversible state of decline, with nothing to stop the glaciers in this area from melting into the sea. 40 years of observations indicates that the glaciers in the Amundsen Sea sector of West Antarctica have passed the point of no return. These glaciers already contribute significantly to sea level rise, releasing almost as much ice into the ocean annually as the entire Greenland ice sheet. They contain enough ice to raise global sea levels by 1.2 meters and are melting faster than most scientists had expected. It will require an upward revision to current predictions of sea level rise. The glaciers flow out from land to the ocean, with their leading edges afloat on the seawater. The point on the glacier where it first loses contact with land is called the grounding line. Nearly all glacier melt occurs on the underside of the glacier beyond the grounding line, on the section floating on seawater. Just as a grounded boat can float again on shallow water if it is made lighter, a glacier can float over an area where it used to be grounded if it becomes lighter, which it does by melting or by the thinning effects of the glacier stretching out. The Antarctic glaciers have thinned so much they are now floating above places where they used to sit solidly on land, which means their grounding lines are retreating inland. The collapse of the sector of West Antarctica appears to be unstoppable. The fact that the retreat is happening simultaneously over a large sector suggests it was triggered by a common cause, such as an increase in the amount of ocean heat beneath the floating sections of the glaciers. At this point, the end of this sector appears inevitable. We are heading toward the particular sector of West Antarctica draining into the Amundsen Sea. This sector is drained by 6 glaciers. The biggest ones are Pine Island Glacier and Thwaites Glacier. The speed of the glaciers measured by satellite is shown in color code. Red is fast, blue is slower, and green is the slowest. The glaciers flow into the sea and form floating extensions called ice shelves. In red is where the flow speed is increasing almost every year. The darker the red, the more the glacier has been speeding up. You see that all the glaciers are speeding up. Now we focus our attention on the Smith Glacier, which is a smaller glacier but which has experienced some of the most dramatic changes. The grounding line of Smith Glacier in 1996 was at the transition boundary between the blue color of the ice shelf and the white color of ice resting on the continent. Now we transition forward 15 years. The grounding line is 35 kilometers farther back, a retreat of 2 kilometers per year. If we could peel off the ice from the continent and see the bed, this is what it would look like. The arrows indicate the direction of flow of the ice and the color indicates the speed. Blue is slow, red is fast. We see that the glaciers flow on top of major subglacial valleys colored in brown. The darker the brown color, the deeper the valleys. As the glaciers retreat, they will follow these deep valleys. There is no mountain or big hill along the way that could act as a barrier to hold these glaciers back. The glaciers speed up, the grounding line retreats, the deep valleys that are sloping inland all reinforce each other to make the retreat of ice in this part of Antarctica unstoppable. And this is happening right now. The tipping point for Antarctica could be triggered by a global temperature rise of 3 degrees centigrade, above the pre-industrial era. Scientists have increasingly issued warnings over the fate of the huge amount of ice stored in Antarctica, which, if it all melted, would raise global sea levels by 57 meters. Antarctica is being winnowed away by a warming atmosphere, as well as the warming oceans, with warming seawater entering crevasses and gnawing away at pinning points that hold enormous bodies of ice to submerged bedrock. A rapid acceleration of melting could cause a cascading effect, where huge amounts of ice and water flow uninterrupted into the Southern Ocean. Thwaites Glacier is of prime concern. Thwaites is one of the fastest melting spots on the continent, believed to be pouring about 50 billion metric tons of ice into the ocean each year on its own. The already melting Thwaites Glacier, roughly the size of Florida, may already be responsible for 4% of global sea level rise or more. Thwaites contains enough ice on its own to raise the world's sea levels by at least a couple of feet. Thwaites Glacier is a fragile piece of one of the most rapidly changing places on Earth. Thwaites elevation falls by several feet every year. If a glacier collapse occurs in the next decade or century, it will be Thwaites Glacier.